Hello everyone, my name is LIU Qicong and I'm from Waseda University. Today I'm going to present to you my paper titled Adversarial Multitask Learning Based Bug Fixing Time and Severity Prediction. Okay, so here's the outline of today's presentation. First, I'll do the introduction, and second, I'll introduce to you the methods I used in our experiment. The third, I'll introduce to you the experiment and the results, and then I'll do a little discussion. Finally, I'll conclude all the presentation and introduce our future work. Okay, so bug report analysis is a very important topic in software engineering. There are many bug reporting systems, aka BRS. For example, Bugzilla, which is a client server, BRS, and Azure DevOps Server, and GitHub. They are built to facilitate software quality assurance engineers and software systems developers to monitor reported bugs in their work for the sake of enhancing software quality. And all stakeholders can create bug reports, and they often contain valuable data for software quality assurance. There are many data in a bug report. For example, there are some structured data like report date, priority, severity, status, assignee, and etc. And there are also some unstructured data like the description, the image, and all the discussions in the bug report, and etc. Conventionally, assign the severity and priority take a lot of time of the developers and software quality assurance engineers. So many researchers today focus on automated severity and priority assigning, and also bug fixing time prediction. Okay, so there exists many single-task learning for bug report analysis. For example, knife-based, support vector machine, recurrent neural network, convolutional neural network, capture neural network, and etc. So, for multiple related tasks with large-scale data like the priority and severity prediction, along with the bug fixing time prediction, training single-task learning models for each task is time-consuming and has a relatively low accuracy. Okay, so next I'll introduce multitask learning. What is multitask learning? It's very effective for improving performance of machine learning models on similar tasks or related tasks. Learn from these multiple related tasks in parallel while using a shared representation. That makes multitask learning learn knowledge from each task and then help other tasks be better learned. Okay, but multitask learning also have inherent drawbacks. For example, its shared feature space could often be contaminated by task-specific features from certain tasks, and the other tasks would suffer from the deviation of feature values led by such contaminating features. Okay, then how to address such drawback? I'll introduce to you the adversarial multitask learning. Adversarial learning is derived from Ian Goodfellow's generative adversarial networks, GANs. And in Such in this multitask shared private model, on the left, you can see that many task-specific features have contaminated the shared feature space. For example, this blue one here and this red one here. And also, in the right adversarial shared private model, you can see that no task-specific features have contaminated the shared feature space, which then led to a more effective shared model. Okay, so now I'll introduce to you our method using the adversarial multitask learning model. This is a non-adversarial multitask learning CM model that we use as a comparison model. It uses a shared private CM model structure. It has two different private models here, one for bug facing time CM, one for bug facing time prediction, and one for bug severity prediction. This is the adversarial multitask learning CM model. You can see that besides the shared CM layer here, it also has a discriminator behind it. So how does it work? The shared convolutional layer generates its shared features and feed it into the discriminator. It works against it. The discriminator here is also a multi-layer neural network, and the discriminator tries to figure out where this shared feature comes from. For example, if this shared feature comes from the bug fixing time task or the bug severity task. And the generator tries its best to prevent the discriminator from making the correct predictions. Okay, so now I'll introduce to you the experiment settings and the corresponding results. We used over 32,000 bug reports collected from Bugzilla, which is a bug reporting system held by Mozilla, and we use the comments of each bug report as the data field. And as for the target fields, we use the bug fixing time and severity of the bug reports. As for the results, you can see that here is the adversarial loss chart. You can see that after 9 epochs, it reaches a low point, and you may wonder, what is the adversarial loss? The adversarial loss is used to measure whether or not the discriminator could reliably predict the task based on the features that was fed by the generator. Okay, so, and as you can see in the right diagram, the average test accuracy improves by 2.19% compared to the single task learning CNN model. And I'll discuss about the research questions and the answers. Okay, so we have two research questions here. The first one is, can a multitask learning CM model precisely categorize bug reports based on severity and bug fixing time? The answer is yes. A multitask learning-based CM model is applicable to bug report triage. The average test accuracy of bug report classification tasks on Bugzilla dataset is 83%, and the best task here, which is bug fixing time prediction, has an accuracy greater than 89%, providing strong evidence that multitask learning CM model can be good option for bi-report triage tasks. And the second research question is that does the adversarial multitask learning CLM model outperform both single-task CLM model and multitask learning CLM model in bi-report triage tasks? The answer is also true. As shown in former slides, the adversarial multitask learning CLM model outperforms the normal multitask learning CLM model in both tasks, and the margin may become more significant if more related tasks are involved and more task invariant features can be extracted. And you can see this conclusion later. Okay, so here is the further discussion. The correlation between tasks. What does the correlation between tasks affect the performance of the adversarial multitask learning model? Okay, so as you can see, the bug severity prediction task did not perform so well in our previous results. So we've trained several other models since then. And as you can see here, when we add the priority into the multitask learning model, and we train these three tasks together, and you can see that the severity, the accuracy of the severity task has improved almost 10%. That's a very huge improvement. And it can be inferred from this result that the bug severity prediction and bug priority prediction are more related tasks. Thus, which means that they share more task invariant features that can be extracted for the shared convolutional layer. Okay, so I'll conclude my research and talk about the future directions. Okay, so based on the fact that most bi-report analysis tasks are closely related, and we can say that adversarial multitask learning can be very useful in such tasks. So we propose this kind of adversarial multitask learning CLM model, and we improve the performance of each text classification task from the error rate of 16.33% using a single task CLM model to 10.75% using our adversarial multitask learning CLM model. As for future work, we all know that multitask learning is actually a form of transfer learning. So our adversarial multitask learning CLM model also shares some good features of transfer learning. Thus, the very pure shared feature space extracted from our adversarial network can be used in newly built bug reporting systems, which means that even if these kind of newly built bug reporting systems don't have many bug reports available for training, we can also transfer the extracted knowledge to it and get good results of the bug report analysis tasks. It can be really exciting, and it addresses the problem of transferring a well-trained bug report triage model to a newly built bug reporting system, which is very critical in industrial practices. Okay, thank you for listening. That's all for today's presentation. Have a nice day, and thank you.